Good afternoon, everyone. I am Madhavi. I am pursuing computer science and engineering in VIT Chennai. I'll be presenting an cryptographic solutions for digital twin security in smart cities. With the rapid growth of smart cities, digital twins, virtual replicas of physical systems are increasing, used for real-time monitoring, decision making, and predictive analysis. However, the integration also brings significantly security and privacy challenges. The main purpose of this presentation is it aims about to explore how cryptographic techniques can safeguard digital twins, ensuring confidentiality, integrity, and trust in smart city infrastructure. So first, we'll see uh, what is how digital twin security is in smart cities. As cities become smarter with IoT devices, sensors, and AI-driven systems, security becomes one of the most critical challenge. In this presentation, I will explain what digital twins are, why security plays a vital role, and how cryptography helps us to build a safe and resilient smart cities. And what is digital twin means? A digital twin is a virtual replica of physical object, process, or system image, a real world asset like building, traffic light, or energy grid. Being monitored in a digital world, this twin continuously receives real time data from sensors, enabling monitoring and simulations and predictions. In smart cities, digital twins are applied to manage traffic, energy distribution, and traffic flow and waste management and even public safety. They help they help administrators makes faster data-driven decisions and as well as useful as they are. Twins are highly dependent on secure reliable data. Without strong protection, they become vulnerable to cyber attacks so that attackers can easily attack. So why is it security is critical in digital twins means as it's absolutely security in digital twins is critical because mainly there are four main aspects. They are data integrity, confidentiality, availability, and authentication. If someone tampers with the data, a wrong signal could cause massive traffic jam, over outage, or even accidents. So this tells about data integrity. And cities collect sensitive data such as citizen movement or energy consumption patterns, which must stay private. This tells about the confidentiality. And if attackers disable system services like traffic control or emergency response, they could collapse. This tells about the availability. If only authorized devices and systems should interact with the twin, otherwise malicious actors could inject false data. So this talks about the authentication. Without authentication, the outsiders may attack the data and spreads the false informations to outsiders. So in short, we can tell that a single breach in a digital twin can have real world consequences. Next, why the cryptography is the foundations of digital security means to secure the digital twins, we rely on to cryptography. This is the science of protecting data against advisories. There are mainly three concepts here involving. They are encryption, hashing, digital signatures. These are the cryptographic techniques we use to for digital security purpose. And in encryption, we ensures the confidentiality by making data unreadable to outsiders. And in hashing, will provides integrity so that we can detect any change in data by using hash functions and digital signatures. It provides authenticity or non-repetition, meaning data truly came from who it came to. In smart cities, cryptography is not just an option, it is the backbone of the security. And first here, data will transist, and next it will be reset and by using some things, and next data authentication. By in device authentication, only the authenticity on non who have the authenticity, they only can access this. Next, they access control. These are the four cryptographic solutions for digital twin security. Next, we are going to talk about the role of PKI. PKI stands for Public Key Infrastructures. It is one of the most major cryptographic tool. This system uses digital certificates to establish the trust between devices. For example, if we take the smart city as the example, in this, each traffic sensors or environment sensors can be issued a certificate. Then the certificates provides a legitimate part of the network, not an imposter. Next, if PK also enables encrypted communication, so that data traveling from the device to digital twin is protected from interception. So without PKI, attackers could easily spoof devices and send false information to others. And next, we are going to talk about digital security signatures for integrity. It is also one of the essential cryptographic tool for security, that is digital signature. Think of this is the unique fingerprint for data. A digital signature is created with a private key and it is verified with a public key. For example, if we take a for example, if we take when a sensor sends temperature or pollution data, it digitally signifies it. The city central system can then verify the signature to ensure two things. The data really came from the sensor or it has been modified along the way. This is the critical for preventing tampered or fake data from entering the city's decision-making process. Next, managing cryptography keys. And now all the security techniques depends on a strong word, that is key management. If cryptography keys are mishandled, the entire system collapses. So for that we have mainly four key managements. They are key generation, key distribution, key storage, key revocation, and destruction. Key generation in this will creates a strong random keys. Then we securely sharing keys with only authorized parties. That means we are distributing keys only for authorized parties. Next, we'll store that keys by protecting so that others can't be stored. Next, we'll revoke it on destruction. If key is compromised or it may be revoked immediately, means if the date is expired, then it can be destructed. So this process ensures that even if a hacker compromises one device, the whole city is at risk. So that key management is essential. Next, blockchain. Blockchain and distributed ledger technology. Here we are going to talk about blockchain can also plays a powerful role. A blockchain provides a decentralized and immutable ledger for recording data or proof ledger. Every record added in cryptography linked to previous one so that no one can secretly alter the past data, and the transactions are cryptographically linked, making them tamper proof. and it also can be used to record critical sensor data, ensuring an unalterable history. And for example, if we take a public safety log in smart cities for emergency events like a fire alarm or police dispatch or ambulance call is recorded on a blockchain. These guarantees an unalterable trustworthy record so that it can be audited at any time. So in the short, we can tell that blockchain brings transparency and immutability to smart city data. Next, what are the future trends? What what are the future trends and challenges on these cryptographic solutions in digital twin security means? Looking ahead, there are mainly three major securing data twins are quantum computing, scalability, and lightweight cryptography. As nowadays the world is technology is developed in the world, so quantum computing plays a major role according to the developed technology. So quantum computing means future computing com- future quantum computers could break today's cryptography algorithm, so that we need to prepare with quantum safe cryptography, so that we need quantum computing. We use quantum computing trend. And next, scalability. It means a smart city might have millions of IoT devices. Securing them all efficiently is a big challenge. For example, in a city, we can get a lot of information from the city. So to avoid from the attackers, secure makes a difficult task. It's a big task. So that is scalability. And next, lightweight cryptography means developing solutions for resources, means many sensors are resource constrained with a little processing power, so lightweight algorithms are required. These challenges remind us that cybersecurity is not one-time fix, but an evolving process. These are the future trends and challenges for this digital twin security. So conclusion, a secure future means to conclude cryptography is not an optional. It's a fundamental. Without digital twins can't be trusted. That means they are the fundamental for the security and trust for smart cities. And by applying a layered security, that is encryption, PKI stands for public key infrastructure, and digital signatures, and blockchain and strong keys management. These are the can create smart cities that are safe, resilient, and intelligent smart city. So in the simple key message, we can tell that digital twins plus cryptography is equal to secure smart cities. That means digital twins plus with the cryptographic solutions, we can build a safe, resilient, and intelligent smart city. Thank you.